How do you calculate stress in material components? Imagine trying to figure out how much force a bridge or a building material can handle before it starts to give way. That's where calculating stress comes into play. When engineers design anything that bears weight or force, understanding stress helps predict if the material will stay strong or break. Stress is simply the force acting on a material divided by the area over which that force is spread. Think of it like pressing your hand against a wall. The harder you press and the smaller your hand, the more pressure you exert. Mathematically, stress equals force divided by area. The force is measured in newtons, which is a unit of push or pull, and the area is in square meters. The result is expressed in pascals, which tell us how much force is applied per square meter. There are different types of stress to consider. Normal stress happens when the force is straight on or away from the surface, like pulling on a rope or squishing a sponge. Shear stress occurs when the force is parallel to the surface, making layers slide past each other, like rubbing your hands together. In real-world parts, stress can be more complicated. For example, a beam might experience bending stress, which happens when a force causes it to curve. To calculate bending stress, you multiply the bending moment by the distance from the neutral axis to the outer edge, then divide by the moment of inertia. To understand the full picture of stress at a point, engineers use tools like stress tensors and Mohr's circle. These help visualize how stresses change when you rotate or shift the material. Mohr's circle is especially helpful because it shows the maximum and minimum normal stresses and the maximum shear stress, which are critical for predicting failure. Knowing how to calculate stress helps engineers see where a material might fail. If the stress exceeds the material's strength, cracks can form or the component can break. That's why understanding stress is vital for designing safe, reliable structures and machines. In simple terms, calculating stress involves measuring the forces acting on a component, dividing those forces by the area they act on, and then using specific formulas for different types of stress. Whether it's pulling, pushing, or twisting, these calculations tell us how close a material is to its breaking point. This process helps explain why some parts break under certain loads and guides us in making stronger, safer products.